Assalamu alaikum.
Walaikum assalam, sir. How are you, sir?
I'm doing fine. Okay. Do you have any doubt from last class to any one of you?
No, sir, no doubt.
What we have done in last class?
Sir, normal reaction.
Normal reaction based on pseudo force.
Yes, sir.
Okay. I defined you lift problem.
Yes, sir.
The next term is equilibrium of concurrent forces. What do you mean by concurrent? Let me define you. You may have learned this particular term in your class 9 chapter in mathematics called Euclid's postulate, in which it says you can draw infinite line from a single point. So all the line which are passing from this particular point is termed as concurrent line. If a number of lines or a straight line are passing through a single point, it will be termed as concurrent line. And if you want to define current force, it means if a number of forces acting on a single point or a single body, it will be termed as concurrent forces. So if large number of forces are acting on single point, these forces are called concurrent forces. Let's say you have F1 F1, F3, and so on to the forces are acting on this particular point having mass m. And if sum of all forces acting on this particular object is zero, then it will be termed as equilibrium of concurrent force. Equilibrium is if sum of all forces acting on a single point and it equals to zero, it will be termed as equilibrium of concurrent forces. So there would be no acceleration of block in any of the direction, as these all forces will balance each other. Now, if any one force is removed, let's say F1, F2, Fn, any one force is removed. If any one force is removed, so will be any acceleration particular object or not? Hamza, let's say this F1 is removed from this point. So define whether any acceleration would be for this mass along direction or not.
Sir, your voice is lagging a bit.
Hello, is it clear now?
Yes, sir.
Yes, sir. It is.
Okay. My question is, if one of force is removed from this particular entire number of forces, then will there be any acceleration to this particular mass or not? So you'll say this will be F3, F4, F5, F6, and so on. So if net force initially acting on this particular mass was zero, so if you remove any of the force, there will be a force opposite to this particular term, which must be initially balancing this. So if you remove this, there will be effect of F4 in this particular direction, which will accelerate this particular mass towards. Is it clear?
Yes, sir.
Say acceleration in this particular removal of force would be F4 divided by mass. This to the all forces still will cancel out each other, but this F4 will not cancel due to this particular removal. So we'll say it will be acceleration is equals to F4 divided by mass. And now F4 is in opposite to this particular F1. So you will also say F removed by mass in opposite direction will be termed as acceleration of this particular body. Is it clear? Iba, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Have you done?
Sir, done.
Now, due to this particular concurrent forces, I defined you one relation in vector about Leibniz theorem. It was based on vector. So let's say if you have forces acting on a particular object along the direction F1, F2, and F3. And if sum of all forces acting on this particular block zero, there is a relation between these three forces. Let's say opposite to this F1 is alpha, opposite to this F2 is beta, and opposite to this F3 is gamma. So if sum of all forces acting on this particular block is 0, so according to Levy's theorem, it will be F1 divided by sine of alpha, F2 divided by sine of beta, and F3 by sine of gamma. I had already defined you this particular term in vector part. Is it clear?
Sir, what's the name again? Lenning's theorem?
Levy's theorem, Lami apostrophe S theorem. I defined this particular term in addition of vector. Just is it clear till this part?
Yes, sir.
Yes, sir.
Okay, just write it down. Have you all done till this part?
Yes, sir. Then.
Sunan,
Done, sir.
I'm giving you one problem and I will define you how to solve it by two different ways. Let's say we have a string. This is one of the support. This is another support. And there is a block mass 5 kg at this instant. Let this particular angle is 30 degrees. So you have to find tension in each string. Find tension in each string. I'm defining how to solve it. We have two ways to solve this particular problem. First, by breaking component of each part along the respective x-axis and y-axis. Let's say we have one along y-axis and other along x-axis as different component. This particular string is at some inclination 30 degree with respect to x-axis, so it will be along this direction. This string is along this direction, which is opposite to x-axis. and this is string along vertical direction or negative y-axis, so it will be like this. Let's say tension in this particular string and the point of contact opposite would be T1. Tension in this string opposite to point of contact would be T2. And would be a force due to this mass along downward direction. We call it as mg. Since there is no movement of this particular point, so it will be termed as equilibrium point, or you will say net force would be 0. Now, just break this particular tension T1 due to this inclination into two parts. First would be along this direction, so it would be termed as T1 cos 30 degree, and one would be along this direction, so it would be termed as T1 sin 30 degree. Is it clear to this part?
Sir, why have you taken that sine 30?
If you have a vector which is inclined at an angle, it will have two components. One, cos component adjacent to this particular theta will be termed as base component, and there will be opposite to it, sine component. So I have just resolved this particular vector into two components depending upon that particular theta. Is it clear?
Yes, sir.
Just see, whenever you have a vector A inclined at some angle theta, so it will have adjacent component along this direction and this direction. So along theta, it will be A cos theta. Opposite to it will be A sin theta. Is it clear?
Yes, sir. Understood.
I defined you this particular term in resolution of in chapter 4. Okay. Now, since the net force acting on this particular point is 0, so the total upward force must be equal to total downward force. Total left-hand side force must be equal to total right-hand side force. So just comparing, you get T1 sin 30 is equals to m times of g. So on solving, T1 would be equals to 2 times of into g. So it will be 100 Newton. Now,
Sir, by the way,
if
how
you
did
compare
half
these
come
three
again?
equations, sine of 30 degrees equals to
Okay, 1/2. Okay.
similarly, if you compare horizontal component T2 along left hand side and T1 cos 30, which is equals to root 3/2 along right hand side. Value of T1 is 100, so it will be 100 root 3 divided by 2. So you will get 50 root 3 Newton. This is one way to solve T1 and T2 using component method. Is it clear till this part?
Yes, sir.
Yes, sir.
I'm defining the same problem using Learnivio's theorem. Let's say you have one vector along this direction, the other is along this direction, and the other is along this direction. So first of all, you have to define inclination between each vector. This is T1, this is T2, this is vertical direction NG. Let's say this particular inclination is 30 degree and this is 90 degree. So total inclination this point to this point will be 120 degree. Now, total angle from this point to this point will be 90 plus 60. So it will be 150 degree. And this will be just 90 degree. Is it clear?
Yes, sir.
Sir, how did you take 150 degree again?
If you draw a vertical line at this point, this is your 30 degree, so this must be 60 degree, and this must be 90 degree. So 90 plus 60 will be 150 degree. Is it clear?
Yes, sir.
Now, which simply states you T1 divide by angle opposite to it. So it will be 90 degree. T2 divide by angle opposite to it, which is 120 degree. And mg, third force, and angle opposite to it, 150 degree. Now just compare this equation with this and this with this. I find you how to solve sine of 120 degree and how to solve sine 130 degree. Sine 120 degree is same as sine 60 degree and sine 150 degree is same as sine 30 degree. Just compare these two terms, you will get T1 and T2 as same as for the previous part. Is it clear to you all, this part?
Yes, sir.
Thumbs up? Okay, let's write it down. You're done till this part.
Yes, sir. Done.
In this calculation, okay. So this is all about this motion, Newton's law of motion. The next is friction. So first of all, what do you mean by friction? So you'll say an opposing force to roughness of the two surfaces in contact, which opposes the relative motion of two bodies. Suppose if we have a surface like this, and there would be a block on this part. Yes. So if you magnify this whole part at this point, you will observe a zigzag path like this. Due to which there would be interlocking between these two surfaces. So this is roughness of two surfaces in contact, due to which there is an opposing force which opposes the relative motion of surfaces in contact. Friction is nothing but an opposing force which opposes the relative motion of a body. Is it clear? What do you mean by friction?
Yes, sir.
Now we may divide this particular friction into two parts. First is called slide friction, and next is called rolling friction. We may divide sliding friction into two parts. First is called static friction. Next is called kinetic friction. And third one is called rolling friction. I'm explaining you these all three terms. Let's say in first part, there is interlocking between two surfaces at this particular point. This is interlocking due to roughness of the two surfaces which is in contact. Let's say this particular interlocking has maximum limit of interlocking of up to 10 Newton. It means below 10, there will be no movement in this particular upper block on this particular surface. So if I define acceleration of this particular block on this surface, so there will be F external, frictional force, and acceleration. I just assume this particular interlocking to be 10, means this is maximum opposition caused by this interlocking. So in first part, if you take F external to be 1 Newton, there will be no movement in this particular block since this interlocking has maximum value of 10 Newton. So acceleration in this particular case would be 0. Now, if you calculate equation to find acceleration for this part, it will be A is equals to net force, that is F external minus friction divided by mass of body. So in this part, since acceleration is 0, so this whole part would be 0. So if you simplify it, you will get frictional force equals to this particular external force. So this will be just 1 meter. Is it clear how I got friction force to be 1 Newton? Hamza, is it clear?
Sir, can you explain it once again?
Okay. I have just assumed this particular interlocking between these two surfaces having maximum value of 10 Newton. So if you apply external force of just 1 Newton, so there will be no movement in this particular block on the surface. So acceleration would be 0. Now put this acceleration in this part, you will get frictional force is equals to external force. So as external force is of just 1 Newton, so frictional force must be equals to 1 Newton. Similarly, if you increase this particular value up to 10 Newton, this frictional force will also increase quickly to reach its maximum value of 10 Newton. Till this acceleration in this particular system would be 0. Now, if you further increase particular external force by any small change, let's say 10.1, 10.2, this block will overcome this particular maximum interlocking and then start moving. So this is the last limit of moving this particular block over this surface. So this last limit is termed as limit friction or maximum static friction. Is it clear?
Yes, sir. Yes, sir.
Okay. Now, if I draw a graph representing this whole situation, so you will see from this term, as F external is directly proportional to friction up to its maximum value. When it has reached its maximum value, it will become constant like this. So this particular term, maximum value of friction, is termed as limiting friction, or you will say maximum static friction. So this is termed as F maximum static. And when body start moving constant acceleration, so this force will become constant. We call this particular term to be kinetic friction. So up to this part, This term is static friction, and beyond which is termed as kinetic friction. This is your external force versus friction graph. Is it clear till this part?
Yes, sir.
Okay, just write it down. Have you all done till this part? Iba?
Done, sir.
Okay. Now from this, you'll conclude First, if external force is than maximum static, so acceleration of this particular body would be zero, or there would be no motion in this particular object. So frictional force would be equals to external force up to this part. Second, if external equals to maximum static, then at a particular strength, object will tend to start or tend to slide. Object will tend to slide. So friction in this particular case would be equals to maximum static. And in third part, if external is greater than maximum static, so there would be some acceleration in which frictional force would be equals to maximum static or kinetic friction, depending upon value given in the questions. Is it clear till this part? Just remember these three statements regarding frictional force. Hamza, is it clear?
Yes, sir.
Now, I'm defining you some formula to calculate this particular frictional force. So there are some laws of friction. First, all frictional force would directly proportional to normal reaction of body. Next, it will depend upon the roughness of surfaces in contact. So for maximum static, let's say static friction, F maximum static would be directly proportional to normal reaction. If we remove this particular proportionality by putting some constant of proportionality, it will be mu static times n. This mu is termed as coefficient of static friction. Which is a pure number, unitless quantity. Is it clear till this part?
Yes, sir.
We just write it down. I'm finding how this maximum static friction would be at different position at different time. And we'll return to this part. Salman,
Yes, sir. Done right.
Iba,
Yes, sir. Done.
now I'm defining how to calculate normal reaction for this friction. Suppose you have a surface on which there is a block like this. So due to this particular block, the mass must be applying a gravitational pull on this particular surface. In return, surface would apply normal reaction opposite to it. So N would be equals to mg in this condition. Let there is some inclined path having some inclination theta with respect to horizontal. And let's say you have a block at this point, have mass m. So it will be experiencing a vertical downward force along this direction, which will have two components, one perpendicular to the surface and other along this particular line. So the normal force opposite this particular surface would be along this direction. Let this particular term to be normal reaction. This is gravity. Let's say this is theta, so this will be theta. So this component will be termed as mg cos theta, and this will be termed as mg sin theta. So which component will be taken as normal reaction for this? Hamza? Which component will be normal reaction in this part? Normal reaction is nothing but the force perpendicular to the surface is termed as normal reaction. So you will say normal is equal to mg cos theta. Is it clear? Mg is
Yes, sir.
equals to normal reaction in this first part. In the second part, it will be equals to g cos theta. In third part, I'm defining you. Let's say if there is a force acting along this direction at some inclination theta with respect to horizontal. Let's say this particular force to be F. So it will have two components. One will be along this direction and the other would be along this direction. So this particular term would be taken as F cos theta, and this particular term will be taken as F theta. Due to this particular body having mass, it must be experiencing a downward force of m, and against it, there would be a normal reaction like this. So the total upward force must be equal to total downward force. So if you compare them, you will get F mg minus F sine theta as normal reaction in this form. So for any of the problem, the total force opposite to the perpendicular surface is termed as normal reaction. Is it clear?
Yes, sir.
Now I'm defining one more term related to this. Let's say there is a van which is going horizontally with some acceleration. Let's say A, and there is a block attached to this particular surface at this point. Since this particular system is accelerating, so there will be zero force on this particular block along this direction, which is mg. To balance this particular MA, due to this particular surface, there will be a force opposite to it termed as normal reaction. So from this, you will say normal reaction would be equals to m times of A. So we'll say normal reaction is nothing but perpendicular force opposite to surface. Is it clear, Hiba?
Yes, sir.
We just write it down. Have you all done to this part?
Yes, sir. Done.
Salman,
Done, sir.
there is a block at this particular point having 2 kg, and the roughness at this particular point let's say mu is equals to 0.7. So maximum static, F external, and acceleration of particular block, which equals to F external minus frictional force divided by mass, and also define frictional force experienced during this. F external would be force along this direction, which will be component of mg. Just try to simplify.
Sir, how to find
Just
fx?
use this concept. This will be termed as F external. This will be a normal reaction from which you will calculate frictional force. Just to solve incoming Let me give you some hint. To break the component of mg, one would be along this direction as mg cos theta, and which will be nothing but normal reaction. There would be one component along this direction, mg sin theta, which will be taken as f external. So first of all, if you find maximum static friction, it will be equals to mu times normal reaction, and normal reaction this part is mg cos theta. Hamza, tell me the value of mu s.
Sir, 0.7.
Good. Mass of block is,
Sir, 2 kg.
and take the gravity to be 10. Cos of 30 degree is root 3 by 2. So this 2 and this 2 would cancel out. Root 3 is 1.7. If you multiply it by 7, it will be 119 into 10. So it will be 11.9 Newton. Or you just take it as 12 Newton. Is it clear to this part?
Yes, sir.
Now, in this part, we have F external is equals to mg times sine theta. So m is mass of block, that is 2 kg. G is gravity, which is nothing but 10. And sine of 30 degree, which is equals to 1 by 2. So on solving, you will get 10 Newton. Khalid, is it clear?
Yes, sir.
Now just compare which of the two forces in these two is greater, F maximum static or F external.
Sir, F maximum static.
So just compare from this. If F external is less than maximum static, there would be no acceleration in the block. It will remain at rest. Then frictional force in this condition would be equals to the external force. Is it clear?
Yes, sir.
So from this, you will say acceleration of the block would be 0, or there will be no movement in the block, and frictional force experienced by this particular block would be equals to external force, that will be 10 Newton. Hiba, is it clear?
Yes, sir.
Do you have any doubt to any one of you? Salman?
No doubt, sir.
Good. Just write it down. Have you all done till this part?
Yes, sir.
Now there is two more relation related to this particular static friction. One is called angle of friction and the other is called angle of repose. Let's say there is a surface on which there is a block at this point. So if you apply any external force to it, it must be experiencing an opposing force along this direction. Let's say this is maximum static friction. So there will be normal reaction perpendicular to the surface along this. Now, if you take the resultant of this normal reaction and this maximum static friction, it will be along this direction. This is your resultant of normal reaction and maximum static friction. The inclination between these two terms is termed as angle of friction. So if F external equals to maximum static, then inclination between resultant of normal reaction and maximum static to the normal reaction is termed as angle of friction. Now, if you solve this particular angle, you will get tan theta is equals to mu static. Just remember this relation. Is it clear till this part?
Yes, sir.
Hamza, any doubt?
No, sir, no doubt.
Okay. Now suppose we have a plane surface and there is a block placed on it, and if you start raising this particular plane to some angle with respect to horizontal, let's say it will be at this instant. After some time, it will be at this instant. After some time, and last, it will be at this instant, maximum after some time. Let's say this particular block at this point having mass m. So when you start raising this particular inclination of plane with respect to horizontal to the maximum value till this block starts sliding on this particular surface. So the maximum inclination of plane with respect to horizontal up to which this block has just started sliding is termed as angle of repose. So in this part, what it actually means, so let's say this particular maximum inclination is phi. So if you break this component, it will be mg sine phi along this direction. mg cos phi would be along this direction. So there will be normal reaction along this. So it must be experiencing a frictional force maximum static along this direction. So it will be the maximum inclination of plane with respect to horizontal so that block just begin to slide is termed as angle of repose. Now, if you further calculate or solve it, you will get tan phi is again equals to maximum static. So from this, you can conclude angle of repose and angle of friction are always equal. Is it clear?
Yes, sir.
Yes, sir.
Just write it down. Have you all done?
Yes, sir. Done.
There is a question. If maximum static friction of a surface is zero point 0.5, find maximum inclination up to which plane will be raised. So in this problem, it is nothing but you have to calculate angle of repose. And we have derived a relation in the previous part. Coefficient of static friction simply equals to angle of repose. So tan phi would be equals to 0.5. So from this, you will calculate phi is equals to 0.5 tan inverse. Is it clear?
Yes, sir.
I'm defining how to solve this. Just remember, if theta is smaller than 30 degree, so tan theta sine theta equals to theta in terms of radian measurement. Now, to convert this angle in terms of radian measurement, 1 degree is equals to 1.74 into 10 raised power minus 2 radian. So let's say this particular angle and this particular point is in term of degree. So if you multiply this particular term by this much amount, you will get in terms of radian, and which must be equals to this value. Therefore, you will say 5 into 1.74 into 10 raised to minus 2, which will be equals to 0.5. Now, if you calculate this particular term, it will be 0.5 divided by 1.7 into 10 raised to minus 2. This point and this point will cancel out, so it will be 5 divided by 17 into 100. So if you divide this term, it will be approx 5.9, and if you multiply this whole, you will get approx 28 or 29 degree. But in actual, for this particular 0.5, angle would be 27. Is it clear? Hamza, is it clear?
Yes, sir, it is clear.
So just remember this particular statement and how to calculate this particular angle. Is it clear to you all to this part?
Yes, sir, it is.
Have you all done?
Yes, sir.
Yes, sir.
Similarly, if you calculate kinetic friction, which will be friction force caused when body is in uniform motion. Frictional force experienced by body in motion. So for this, Fk is equals to mu times of k into normal reaction. This particular term is coefficient of kinetic friction. So if you compare static friction and kinetic friction, the numerical value of this is this much, and it will be greater than 0, but always less than 1. Is it clear till this part?
Yes, sir.
Okay. Now there is one more term which is called rolling friction. Rolling friction is basically due to deformation. Suppose there is a wheel going along a track like this. So if track is more rigid as compared to this particular wheel, so it will get deformed by this much amount due to its rigidity. So this particular surface must be applying a force, or it must be deforming this surface at this given point. So let's say this wheel is going along this direction with some external force. So at this instant, there is an opposite force which causes to deform this particular surface at this point. So this is nothing but opposition to this particular external force. Similarly, if you take wheel of a road roller moving on surface, so this will have a tendency to deform the surface according to its own shape, like this. So at this point, there will be a force from inside on this track to deform its shape according to its surface. So let's say it is going along this direction with some external force F. So some amount of this particular force get utilized in deforming this particular surface according to its shape. So in this condition, as well as in this condition, in both conditions, some amount of force is getting wasted along deformation of wheel or deformation of surface. This loss in force due to deformation is termed as rolling friction. Is it clear? Khalid, is it clear? What do you mean by
Can
rolling
you explain
friction?
again?
Okay, just 1 minute.
Yes, sir.
In the first part, I've taken this wheel to be soft as compared to this track. So this track would have tendency to deform this particular wheel according to its shape. So some amount of force must be experienced by this particular wheel at this instant from this surface to get deformed by this amount. So this force which is acting on it opposite to this particular external force mass decreases this amount by a small amount. Similarly, in this case, let's say a road roller is going along track. So some amount of this external force is utilized to deform this particular surface or track according to its own surface. So in both these two conditions, some amount of force is getting wasted in deformation of either track or within wheel. This amount of force wasting is termed as rolling friction. That's why we take ball or ball bearing, which having a metallic ball, and it must be going along metallic surface. So there will be a minimum deformation in between them. So you will call it as they will offer minimum rolling friction. Is it clear?
Yes, sir.
So rolling friction is basically deformation in object or track. So there is no formula regarding this particular rolling friction, but this is only a concept. Just write it down. Have you all done till this part?
Yes, sir.
Now I'm defining you some problems related to this. Let's say this is your surface on which there is a pulley. This is your first block at this point. This is second block at this point. And there is another block attached to this. If all masses are identical and there is roughness having coefficient mu, so you have to calculate acceleration of system. Find acceleration of system. So how will you calculate this? I'm giving you some relationship. For any of the problem, first of all, define in which direction this whole system would accelerate. So you will say there is only one force which will accelerate this whole system. So it will be along this direction. Is it clear?
Yes, sir.
Now draw all forces acting on this particular block. So one would be along this direction due to gravity, and there would be one force along this direction due to tension in this string at this point. Similarly, there would be one tension at this point, and at this point as well. There would be another tension at this point and at this point as well. Is it clear? How I drawn different tension at different instant?
Yes, sir.
Now, if you want to calculate frictional force at this point, so there would be one force along downward direction, that would be mg, and to balance this, surface must apply opposite rate, that is normal reaction. So if you calculate frictional force for this point, it will be mu times of mg along this direction, and similarly at this instant. So it will be again equals to mu times mg. Is it clear?
Yes, sir.
Khalid, is it clear?
Yes, sir.
Now you can solve this particular question in two different ways. One way to define equation for each part, and then sum up all, you will get acceleration. I'm defining one more shortcut rule to find these type of relation. Let's say you have this particular block. Just make this particular whole system to be straight. So there will be a force at this point, and there would be another at this point. And since this is your pulley, so it must be at this instant. Or let's say I just bring this particular mass straight to it like this. And now on this basis, just draw all the forces acting on this. So first is mg, which is at this point. So it will move to this. There will be one tension at this point, T1, at this point, T1, at this point, T1, and at this point, T1. Similarly, there will be another tension at this point, let's say T2 and T2. And this whole system would be going along this direction with some acceleration A, A, A. Is it clear to you all? I've just
Yes, sir.
bring this particular mass straight to it so that it will be just a straight body system. Now from this, if you calculate using second law, F net divided by total mass. We have one force along left hand side which must be accelerating, and there are one force along this direction which will be friction, and one at this direction which also friction. Just put all these values in this equation and try to find acceleration. Try to solve. Take this direction to be positive and this direction to be negative. And just put all the forces. The forces along left hand side will be taken as positive and right hand side taken as negative. Just apply this rule, put all the values, you'll get your answer. This is another way to solve any pulley system. F net is the net force acting on this particular system along left hand side, that is mg. Along right hand side, T1. Again left hand side, T1. T1 and T1. Next is T2 and friction force. T2 and again friction force. Whole divided by total mass of system. So we have 3 blocks in this whole. So it will be 3 times of m. Is it clear?
Yes, sir.
How I have taken this whole? Hiba, is it clear?
Yes, sir.
Now just compare each term and cut out the term which will be in pair or it will be in opposite direction. So this T1 and this T1 would cancel out. Similarly, this and this would cancel out. Similarly, this and this would cancel out. So what we're left with, just put all the values and simplify it, you'll get your answer. This is the most easiest way to solve any pulley system. If you take out m and get cancel out, you will left with 1 minus 2 times of mu divided by 3 as acceleration of the system. Is it clear to you all?
Sir, what about M?
In numerator and denominator, both will cancel out. So you're left with only the coefficient part.
Oh, okay, sir.
Suppose if you take out common as mg from numerator, you will left with 1 minus 2 mu in bracket divided by 3m. So this m and this m would cancel out. So you're left with g bracket 1 minus 2 times of mu over 3. Is it clear, Hamza?
Yes, sir.
Okay. Khalid, is it clear? Have you all written?
Yes, sir. Done.
Salman, any doubt?
No, sir.
Khalid? I'm giving you one more relation. Suppose if you have surface on which there is two blocks, one is at this instant and the other one is at this instant. This particular block having mass 5 kg or let's say 6 kg, this having 4 kg. So let's say this particular block to be A, this particular block to be B. So you have to calculate, find frictional force at AB junction and B and wall junction. There must be any external force to balance this whole. How to solve it? I'm giving you some relation. Let's say this particular block having mass 6 kg. First of all, try to define its FPD. So it must be experiencing a downward force due to its mass, or you'll say due to gravity. Since this particular force will tend to move this particular block along downward direction, and since in this whole system there will be no movement along downward direction, so it must be experiencing an upward force along this direction. Let's say call this frictional force 1. Is it clear, Hamza?
Yes, sir.
So using this FBD, what you conclude about F1 and M1G, whether they should equal or not? Since there is no movement in this block, so total upward force must be equal to total downward force. So from this, you will say total upward force is equal to total downward force. M1 is 6 and gravity is 10, so it will be 60 Newton. Is it clear?
Yes, sir.
Eba, is it clear?
Yes, sir.
Khalid, any doubt?
No, sir. Sorry, I had net problems.
Okay, no
Couldn't
problem.
respond.
Now, if we want to calculate net force on this particular second block B, let's suppose if you have two surfaces in contact, if move one to forward direction, let's say this particular term to forward direction, so it must be experiencing a frictional force in backward direction, as this particular block is going forward, so it must be experiencing a frictional force opposite to it. Similarly, this second block is going backward, so it must be experiencing a frictional force opposite to its motion, so it must be forward direction. Is it clear? So you will say whenever two blocks are in contact, if one block is experiencing frictional force in forward direction, the other block which is attached to it must be experiencing a frictional force in backward direction. Is it clear?
Yes, sir.
So this block is experiencing F1 frictional force in upward direction. The other block in contact with this one must be experiencing friction force in downward direction. Now, if you draw FBD using its mass, it will must be experiencing M2G in downward direction. Now to balance these two forces, there would be frictional force at the point of contact between block and wall, let's say as F2. Is it clear?
Yes, sir.
So what you conclude about F2 and this particular two term, since there is no movement in block in upward or downward direction, so the total force in upward direction must be equal to total force in downward direction. Is it clear?
Yes, sir.
So F2 would be equals to M2 times G plus F1. Now put the value of F1 to be 60, M2 is 4, gravity is 10, you will get
100.
F2. Good. So it will be 100 Newton. So from this, just remember whenever two blocks in contact, if one object is experiencing frictional force in upward direction, frictional force having same magnitude experienced by second block would be along opposite way. Khalid, is it clear?
Yes, sir.
So from this, just remember, if two surfaces are in contact, then frictional force on them will be equal but opposite in direction at contact. So this is all about frictional force, static, kinetic, and rolling friction. So we have just completed this entire chapter. I have left one part about circular or banking of road, which I will discuss after work, energy, and power. Okay, just write it down. From next class, I will start work, energy, and power, that is chapter number 6. So just revise this whole chapter and try to do more and more problems.
Done, sir.
Salman, do you have any doubt in this entire chapter? Hiba, any doubt?
No, sir, no doubt.
Okay. Have you all done?
Yes, sir. Done.
Okay, then just revise this whole part and try to do more and more problems. Okay, now first. Good night.
Thank you, sir. Allah Hafiz.
Okay, sir. Allah Hafiz.
Love, love.